Yes. It's me. Your ever unblinking, brown-haired, brown sweater-wearing person that blabs about math and then screams at scary games. How's everyone doing? Trick question, I'm the only one here. And that's okay. I'm pretty doggone excited, though. We're going to talk about gravity. And the reason why I'm excited is because I think I've made a decent explanation of why, at least, the equation that you learn about gravity when you're in early physics classes is the way it is. So we'll talk about that. And I also feel super clever because there were certain things that I wasn't necessarily understanding, but I do now. So I feel like a genius, even though it's on topics that you learn when you're like in junior high. But oh well. So such is life. So yeah. I'm gonna just jump straight into it, because it's cool, and I want to explain it. My mouth is not open, but it thinks it's open. My teeth are on my lip. Come on! I guess it's pretty amazing that it, like, at least registers anything at all. Digital avatar technology is cool. I like it. Okay, here we go. So, gravity. My plan of attack, to explain this to you guys, is to first not talk about gravity. First, I want to talk about a math topic that's fairly basic, but for some reason I didn't know why it was the way it was. It's proportionality. Something is proportional to something else. How you make math equations out of proportionality. So we'll talk about that first. The next thing is also a math topic. Flux. No, not FU. FLUX flux. Namely, number of lines penetrating a boundary. After that, I want to talk about mass. Because you can't really understand gravity until you understand the concept of mass. And then we'll finally talk about gravity. Oh, and in our explanation of mass, so like 2.5, we need to talk a little bit about springs. Okay, so with this plan of attack, I feel pretty confident that we'll be able to understand how the heck Isaac Newton got the equation for gravity that he did. So first, proportionality. Here's some notation. Say we have two variables, things that change, y and x. And let's say that y is proportional to x. The symbol that I use to denote proportionality is a tilde. What this is saying is that not only is y a function of x, we also know what that function looks like. Like, I could actually say, well, is y a function of x like a line, or is it a parabola, or is it a cubic, or is it a square root, yada yada yada. When I say y is proportional to x, it means that y and x form a line. So you'd say it's a linear relationship. If you think of the word proportion and proportional, a proportion is a ratio. So when I say y is proportional to x, the reason why we're getting this equation in the first place is because we're saying that the ratio of y to x is always the same number. So for a straight line that goes through the origin, let's say that it climbs 2 for every time it goes up 1. If my x value is a 1, and my y value that goes with that x value is 2, the number that I get from that ratio is 2. If I go in the reverse, so if I go left, I'll go down 2. So if I put in my x value of -1 and my y value that goes with that x value of -2, I also get the same number, 2. So here, the constant of proportionality is 2, which is where the equation y equals 2x comes from. The ratio of y and x is always 2 in this example. So, when we say something is proportional to another thing, especially if we say one thing is directly proportional to another, that means when one thing goes up, the other one goes up, and if you divide their values, you always get the same number. So if I use the x value 2 in this example, the y value I would get would be 4. So an x value of 2, the y value of 4, yep, that gets me the same number, 2. So if I take some arbitrary x value, I don't know, a, I can tell you what the y value will be. It'd be 2a. Because their ratio would have to still equal 2, because we're still going to be on this line. So if I put the x value, some number that I haven't really told you what it is, I know the y value will be double that, because it needs to preserve the constant of proportionality, 2. Now, there's other ways for one thing to depend on another. Like, inverse proportionality. So you would say y is inversely proportional to x. If x gets bigger, this entire fraction will get smaller, which means y would get smaller. So if x gets bigger, y would get smaller. Inverse proportionality. The equation you could write with that is y equals, b over x, where b is just a constant that stays the same no matter what. A very important thing about the constant of proportionality. So when I was talking about a line, it was m. When I'm talking about an inverse proportional relationship, it's this letter b here. What the letter is doesn't matter. What matters is that you're calling it the constant, not one of the variables. This constant is constant with respect to x. If you had a dial with x values and you twisted your dial, the number that m would be would not change. It would just stay where it is. Y would change because y depends on x. It's proportional to x. But m would not change. That doesn't mean that there aren't other dials on a machine that you could wiggle and then make m change. All we know is that m just is a constant with respect to x. If you wiggle the x dial, m will not change. That's the same with this b right here. If I wiggle the x dial, b won't change. But if I have other dials that are not x, and wiggle those, the value of b might change. So if we use function notation for y is proportional to x, that would mean y equals mx. M is not a function of x. And then for y is inversely proportional to x, that would be y equals some other constant over x. B is not a function of x. Now, let's think of a situation where we have some variable, z, and we say that it's proportional to another variable, x. But we also say that z is also proportional to another variable, y. It's possible for something to depend on more than one thing. So our z machine that gives us our z number can have more than one dial. In this case, it has an x dial and a y dial, and when we fiddle around with the x dial or y dial, our z number will change. This is what these two statements say. Is it possible to make one equation from both of these statements? Because right now, we're stuck with two equations talking about how z behaves when you fiddle around with x or y. But is there an equation that we could make that shows just z and both x, y in the same equation? The answer is yes, and this is how you do it. let's make our equation that represents z is proportional to x. So z equals x times some constant of proportionality a. And I just, again, the choice of the letters doesn't matter. What matters is how you treat them once you've labeled what they are. So I said that a was the constant of proportionality. So in this situation, that means that a is not a function of x. If I wiggle around the dial that controls the x value, the value of a will not change. However, a could depend on any other dial. If I wiggled the y dial, the value for a might change. We don't know. So a being a function of y is a possibility. Let's write out our equation for z is proportional to y. So z equals... I can't use a because a was the constant with respect to x. So I just need to pick another letter, so I'll pick b. Because why not? So b x. Alright. Let me get rid of this top stuff. Gone. So then we... No, not bx, by. There we go. That means b is not a function of y. If you wiggle around the value of y, the value of b isn't going to change. But b could be a function of x. What the heck? Ow! Well, hi! Welcome to the stream. Unless you're a follow bot, and then that would be sad. But it seems like you're the only one. So, yo, what's up? I'm Blair. I'm a free math tutor. When nobody has questions, I ramble about random stuff. Oh no. You're also a sentient follow bot. But then, would that mean that you followed out of your own will, and not because you were programmed to do that? If you were sentient. Holy crap. Just put in a good word to me to Skynet so that, you know, I don't get blasted by an Arnold Schwarzenegger-looking android. But yeah, so, free math tutor. Right now, I'm explaining gravity, actually. But first I needed to explain proportionality, because that's a huge reason why Newton's law of gravity looks the way it does. So yeah. What's up? What brings you to my lovely... Okay, I'm not gonna say my channel's lovely, but what brings you to my channel? Awesome! That is a-okay too. You... Like, part of my premise is, like, free math tutor because I want to get education to anybody regardless of how much money they have. But I also am, like, I want to popularize this stuff and show people, hey, you can understand a lot of this really crazy, complicated stuff too. So, watch on. I am more than happy to explain to actual, at least conscious things, if you're still a bot. But yeah, welcome! Okay, now, I have really bad ADHD, so I'm gonna need a second to remember what the heck I was saying. Okay, I know what I was saying now. So, in this statement right here, z is proportional to y. B is not a function of y, but b could be a function of x. And if we had more dials on our z machine, b could also be functions of those other dials. So maybe like a theta dial and a t dial or whatever. But since I've only said that z depends on x and z is proportional to y, we're really only going to worry about our constants being functions of x and y, and that's it. Okay, so I want to be able to make just one equation out of all this stuff. Because they're both talking about z, so it'd be nice if I could just make one equation that describes how z behaves when you fiddle around with the x dial and with the y dial. The nice thing is that these two equations have z in them. And also z is solved for. It's all by itself. So we could use the transitive property of logic. If, a equals b and b equals c, then a equals c, because you just have a link right here. We can take these two pieces and set them equal to each other. So we could say that a times x equals b times y. Now here's something that I'm going to do. I'm going to divide both sides of this brand new equation by b. So here we go. Okay. Also, I'm going to have the y sitting by itself. Actually, no, I'm not going to do that. Alright. Okay, so I have a over b x equals y. Here's a really important thing. Oh, I wasn't supposed to divide by b. The reason why I went quiet is because I was thinking, wait, something's wrong here. I did something stupid. Which should be encouraging to anybody watching, because, somebody as... Okay, I won't call myself stupid, that's not fair. But someone as scatterbrained as me, if I can get this far in math and understanding all this stuff, you definitely can too. Believe me. So we got that. There we go. What the... what? Cool, I'm gonna have a cool red mark on my cheek. Thank you for the follow, T-Ruse. Again, unless you're a follow bot. I'm just really paranoid about follow botted because I got follow botted, a little bit less than a week ago. So now I have not a follow bot. Yeah, see, but that's, what Maddie said. And that's what a follow bot would say if they could actually talk in chat. But yeah, welcome to my stream. I'm Blair, free math tutor, and I rant about random... Oh no. You'll see that I am a master at deduction. And also, my memory is impeccable. Also, shut up and don't contradict me, or I swear I will ban you. But yeah. Okay. So right now I'm just talking about gravity, starting with talking about proportional relationships, and how you can combine proportional relationships together to get one equation. And the reason why I'm saying that out loud is because I have to tell myself, otherwise I will have forgotten what I was talking about. So, here we go. Now, with proportional relationships, note that I said that the letter b is not a function of y. It cannot depend on y at all. If I change the value of y, b should remain the same. I did say that b could be a function of x, because proportional constants are only constant with respect to the variable they're being multiplied by in that equation. So having this x right here is a-okay. If I change the value of x, it's okay if it changes the value of b, because b is not constant with respect to x. I didn't say that. But I did say that about y. Having b equal some stuff times y, or divided by y, is a problem. Because this is saying that b is inversely proportional to y, meaning b is a function of y. But I said right there, that's not true. Now, it wasn't wrong for me to say z equals a times x, and it wasn't wrong for me to say z equals b times y, and it wasn't wrong for me to set ax equal to by. That means there's something special about a that's going to fix everything. Namely, remember how we said that a could possibly be a function of y? That's because it is. If we have a situation where we have a divide by y, and we need that to go away, then we need somebody, either a or x, to be directly proportional to y. And since we said a being a function of y is a possibility, let's assume that a is actually directly proportional to y. Meaning there's some other constant, we'll call it c, that multiplies to y. C is not a function of y. That controls how a depends on y. If I make the statement that a depends on y and it is directly proportional, and I plug that in to my equation that I have here so far, then I get c times y over y times x equals b, and now the y divides out. So I have cx equals b. C is not a function of x, and c is not a function of y, and x is not a function of y. So b is still not a function of y. We're still okay. We haven't broken any bits of our logic. So, this leads us to another really interesting thing. I can replace b in my second equation right here with my constant c times x. So I'm going to do that. So z equals bx. That came from when I said z is proportional to z equals by, because my memory is really good. It's so good it's scary. Y, by. So substituting this into here, I get c times x times y equals z. Bada bing! I took two different statements of proportionality and combined them together into one equation. You can do this with any combo of proportional statements as long as they're all related to the same dependent variable. So if you've taken any chemistry, you would have probably learned that pressure depends upon the pressure of a gas in a container, depends upon how many particles that gas is made out of. It depends upon the temperature of that gas, and it is also inversely proportional to the volume of your container. The bigger your container, the less pressurized your gas is. We can take this, and multiply all three of them together, because they're all relating to pressure. And we get pressure equals the number of particles that make up your gas times the temperature divided by the volume, and then multiplied by some constant of proportionality that does not depend on the number of molecules of your gas, the temperature of the gas, or the volume of your container. Since this is an actual chemistry thing, that is a known constant that has a value that you can look up with units as well, and it's called Rydberg's constant. And lo and behold, this is the ever-famous ideal gas law. Pivnert. PV equals nRT. So, this is how you build equations, especially in the sciences, where you have something that depends on many other things. So you can take seemingly independent statements like, well, I know pressure depends on the inverse of the volume, and, well, I know pressure depends on the temperature, and bring them together into one equation. So that's proportionality. Whoops, hit my mic. Although, I don't know if RTX voice allows random noises like that to go through, so maybe you didn't even hear me hit with the mic. That'd be really cool. Because, Lord knows, I'm using I mean, it's not cheap, but it is cheap. I'm using a cheap little headset microphone. So RTX voice is a godsend, really is. Alright, so step one, talk about proportionality, done. We know how to build an equation out of a bunch of statements saying something is proportional to something else. The next thing that I want to talk about is flux. At least a little baby example of flux. So, the way that I'm going to describe it is like we're in some sort of construction sandbox game. Kind of like Minecraft, but it's not limited to just a square grid of stuff. So you can actually have circles and angles and whatnot. Let's say you have this central point, and you decide to lie down lines through this point. So, here's a line. Here's another line. Here's a line. And also, let's say that you are doing your best to make the lines equally spaced from each other. So here's another line. So what I mean is that the angle between each line is the same. Now, let's say that you want to build some sort of circular fence around this point with all of these straight line patterns on the ground. So let me get a circle going here. We use dark blue for one of our circles. So let's say we got a circle of this size, centered at the center point of this diagram that we're making on the ground, this picture we're making. And then another circle that's a bit bigger, but still with the same center. Okay. Let's say that the radius of our blue circle is a distance of A. So, this radius of the blue circle. My brain decided to stop working for a second, equals A. And let's say the radius of our bigger purple circle is B. So a distance of B from the center dot to the purple circle. That's a distance B. Let's say that the angle between the lines, which is the same everywhere, is theta angle, theta degrees. So trying to keep everything nice and arbitrary. And let's do one last thing. Let's count how many lines coming from the center are found in any angle degrees of a circle. So angle degrees, so theta degrees would be from there to there. How many lines are penetrating the blue circle? 1, 2. The black one and the pink one. Theta degrees would also be from here to here on the purple circle. So how many lines are penetrating the purple circle per theta degrees? Well, oh, that's alright, man. It's good to see you on board, Heretic. And also, I'm very sorry that you have a headache. That sucks. You ever tried a brick? I hear that's really good at helping solve headaches. You just smash your head with it until you fall asleep. Disclaimer, please don't do that. That's just a joke. Forever night-night. But can it solve the illness that it causes? Death. But yeah, disclaimer, please do not hit yourself in the head with a brick. That's very bad. My mom always used to say. That's actually okay. You're right. You got me there. So, yeah, no, the statement stands. The shotgun can, hmm. A shotgun can't prevent death, though. It can't do You're right. Exactly. A shotgun, well, it kind of can, but I'll talk about that later. Reminds me of Skyrim. He asked for a cure for his daughter's lycanthropy, so I gave him an axe. I'm gonna guess that's a Sheogorath quote. Or just some, like, evil, mean somebody. That's still a Daedra, isn't it? Clavicus Vial. Pretty sure. But that's a very good quote, and Elder Scrolls games are still good, even though, you know, they're Todd Howard Productions. Still good. Okay. Okay, gotcha. Also, you didn't hear my voice crack at all. That didn't happen. Okay, so the number of lines penetrating a given angle for a surface of a circle in this diagram is constant, regardless of which circle you're talking about. So, we know that we're going to get 2 lines, or rays, so we'll call these guys rays, because they're like rays of sunshine, leaving the central point. So we get 2 rays per theta degrees. Guaranteed. With the way that we've drawn this diagram. But what about unit length? So, will I get the same number of rays penetrating the surface of a circle per a certain distance? Well, this distance right here and this distance right here we know are not the same length. Because you can actually take a piece of string it about the blue end, and try to string it about the purple part, and it's not going to go all the way. The distance that this purple circle is covering in the same angle is longer than the distance the blue circle is covering. So, I'll call this distance big S. Well, I'll call it SB. And this one I'll call SA for arc length. Yes, S is the traditional letter to use for the length of an arc. Don't ask me why. Maybe it's from Latin. I don't know. Which is why lead is PB on the periodic table. I think the Latin word for lead is plumbum or something like that. But it's like where we get the word a plumb balance or whatever, if we're trying to see if something is level. Or like a plumb bob. There we go. It comes from the Latin word for lead. So, random history and chemistry bonus. Okay. So, the number of rays that I get in the purple arc from the angle theta is still 2. So I get 2 rays per SB distance. And I also get 2 rays per SA distance. But are these ratios of rays per distance going to equal the same number? Like miles per hour. You have to put a number in front of your miles per hour unit. Well, the length of an arc of a circle is equal to the angle that you're talking about for that circle times the radius of that circle. So, for the purple guy, his arc length would be the angle that we're talking about, so it's theta degrees. What's up, Maui? How are you? Times the radius of the purple circle. So its arc length is theta times b. The arc length for the blue circle is the same angle, theta, but then times the distance a. And we explicitly said that a and b are not the same length, because the circles are not the same size, so they're not going to have the same radii. Matter of fact, I explicitly said that b is bigger than a. So not only do I know that these two arc lengths are not the same length, because they don't have the same radii, I know that S of b is bigger than S of a. Now, let's actually replace some values. We're still getting 2 rays from the top, but S of b is theta over theta times b. There we go. And this still has a 2, but then for the arc length, that is going to be theta times a. And my brain decided to die. Okay. Now, notice how both of these things have theta in common? I purposely did this whole thing where the angle is the same. But I did change the radius of these circles. If I kept the angle... No, sorry. If I kept the length that I'm trying to cover the same, so if I use this distance over here and said, okay, I'm only going to look for rays from this place to this place, my number of rays per distance would go down on the purple circle. So what this is showing is that the number of rays that I get within a certain distance on a circle depends upon the radius of that circle. Matter of fact, the number of rays per unit length of a circle is inversely proportional to the radius of that circle. So the bigger the circle away from a point that is radiating out straight lines, the smaller the count of lines penetrating per length will be. That's flux. The three-dimensional version of that would be involving lines penetrating per unit surface area. So if you have a sphere, and you have a point, and you have rays punching through the surface of a sphere, the number of rays punching through a sphere also depends on the radius, but depends upon the radius squared. This is why, say, light sources, so if you have a light bulb, dim by a factor of 1 over the distance between the light bulb and your eyeball, by 1 over r squared. The intensity of the light dims by 1 over r squared. Because light you can approximate as just a bunch of rays being shot out from your light source. And the density of the rays per surface area of a sphere depends upon the square of the radius. That's also why sound waves, so like how intense a sound is, scales with the inverse squared of the radius of the distance between the sound source and the observer. And this explains a super important part of gravity. Namely, the force of gravity scales inversely with the square of the distance between the two massive objects. And surprisingly enough, an inverse squared law was something that people understood at least a decade before Isaac Newton ever published his Principia Mathematica explaining his laws of motion and also his law of gravitation. So inverse squared laws were already a thing, and people were already guessing that massive bodies, so like the sun, was exerting some sort of pull on other objects, so like the Earth, and that the strength depended upon that orbital distance, but 1 over that orbital distance squared. So that's where the idea of an inverse square law comes from. It comes from the flux of rays coming from a central point and penetrating the surface area of a sphere. The amount of rays you'll find per unit surface area decreases by the inverse squared radius, yada yada yada, blah blah blah. Pink elephants. Okay, so we got two things done. We got proportionality talked about, we got flux talked about. The next thing that we need to talk about is mass. Mass is not the same thing as weight. So let me say that right off the bat. Mass is not the same thing as weight. So if you're in a country that uses SI units, when you are saying something is about a kilogram, you're saying how massive that thing is, not how heavy it is. If you wanted to say how heavy an object was, you'd say, oh, that thing's about, 5 newtons. So, in the United States and Britain, when you say something weighs, a few pounds, and not British pounds, but like pounds as weight, that's a weight. If you wanted to say how massive something was, the official term, and I am not lying, is slugs. That's the unit of mass in the, English system. Slugs is mass, pounds is weight. Kilograms is mass, newtons is weight. Another really important thing is that mass is not the same as volume. Just because two things take up the same amount of space doesn't mean that they are made up of the same amount of fundamental stuff. I could have a piece of styrofoam that is a foot cubed, and I can have a piece of gold that is a foot cubed, and please lend me some money if you are able to afford a foot cube of gold, because that's pretty incredible. So, gold. One thing is going to be a lot lighter than the other. A lot easier to move around than the other, even though they take up the same amount of space. The atoms, there are less atoms in, well, okay, let me say it this way. There are less protons and neutrons in this volume of styrofoam than there are in this volume of gold. So, thank you. No. This is something that I've had to confront for a long time. I enjoy explaining things, but I don't like rigid schedules of like, well, I gotta cover this and then I gotta cover this. And I don't want to ever have to deal with people's parents. So, anything below college level I don't want to do. And I also don't want to have to deal with people begging about their grades. So, I like explaining things, but I don't like teaching. And I seriously applaud teachers, because that job is hard. And it takes a lot of skills beyond just being able to explain things well. And they need to be paid a lot more than they are, because they deserve it. So here's the thing about me. I like a little bit about everything. uh, so if you talk about a subject, chances are I might be able to understand what you're saying a little bit. I don't know, like, about everything. Like, there are certain subjects that I'm not really interested in, or I just literally never knew. But a lot of other things, yeah, I kind of put my toe in a lot of stuff. Yeah, um, when I was in... Okay, so, heads up, I'm very old. Okay, I'm not very old. Like, I'm about the same age as Germa 96985. And he's not old, but I mean, he is in his mid-30s, so... So, just to let you guys know, I'm old enough to be some of your parents, maybe. Which is why I'd like to keep the chat and everything PG-13. Crap, what was I talking about? You're too kind. I've had some high school students that I have tutored who, like, when I say how old I am, they're like, oh. But then they go like, well, that's not that old. But it's like, it's too late. I already heard your eyes widen at how ancient I am. And it's fine. I like it. I think it's funny. Oh, I remember what I was going to say. When I was back in college, I actually was considering... Because I think it was becoming an actual area of study. Big history. So... And that, I think, is the actual name of this subject. Big history. So... It's the study of... Done tutoring before, but only in... Gotcha. But yeah, so big history is the study of the universe from its beginning to now. And also, you would probably know some stuff about cosmology and the predictions of what might happen to the universe in the next Google years. So, like, I dabbled in learning a little bit about biology and chemistry. Definitely physics, because I love physics and mathematics. But also a little bit of geology and paleontology, because who didn't love dinosaurs when they were a kid? I'm just a kid that never grew up. And also realized that I'd rather learn about dinosaurs than actually have to go out looking for them and digging them up. So yeah, and also I watched a lot of, like, science documentaries on public TV channels since I was a little kid. So I'm surprised by how much I know, because I don't think I know that much. You just have to kind of catch me on a good day. Alright. Okay. So, we're not talking about big history, though, we're talking about mass. Because we're talking about gravity. Alright, so, mass is not the same as weight. Mass is also not the same as volume. However, if we're dealing with the same type of material, then the mass of your material would be proportional to the volume of that material. Meaning, the more of that material you have, the more mass you have. If you take a cubic foot of gold and then stack another cubic foot of gold next to it, you're going to have double the mass of gold. And if you take a cubic foot of styrofoam and sit another cubic foot of styrofoam next to it, then you have twice the mass that you'd had before. And here's another really interesting thing. Mass is also proportional to weight. At least if you're at rest. If you're in an elevator and you're standing on a scale and you push a button to go up, once the elevator starts moving, you'll notice that you will weigh more as the elevator's going up. But then when the elevator stops again, your weight will go back down to what it normally is. Also, when you go down on an elevator, if you're standing on a scale, you'll notice that you weigh less as you are going down. But at least when you're at rest, your mass is proportional to your weight. Or it's actually better to say that your weight is proportional to your mass. How much you weigh depends upon how much mass you have, how massive you are. These are things that we humans have known for many, many thousands of years, definitely before recorded history. It probably wouldn't be surprising for humans to understand the basic concept of more stuff means heavier, and more stuff usually means more space to take up, 40,000 years ago. Or, heck, maybe even 300,000 years ago, when our species might have actually first started in Africa. So this is something that Isaac Newton definitely would have had in his toolkit when he was coming up with his law of gravitation. And also the idea of gravity existed before Newton. People were thinking that stuff attracts other stuff before Newton's time. But Newton was revolutionary in saying that the stuff on Earth is the same as the stuff in the heavens. And the thing that keeps massive bodies in orbit around the sun, so like planets around the sun, or Jupiter's moons around Jupiter, was the same stuff that made you fall towards the ground when you're on Earth. So that's like the huge thing Isaac Newton did. So the idea of gravity isn't new. The idea that gravity scales with the inverse square root of the distance between massive objects is not new. And the idea that there is a concept of mass that is independent of how heavy something is, and also independent necessarily of how much space something takes up, like, all of these ideas were stuff that existed before Newton. But Newton brought two really important additions to science, which really is why he is so stinking important. And probably the most important one, is his idea of opposing forces. If you are standing next to a wall and you place your hand against a wall, and you push against the wall doesn't necessarily move. Your hand isn't necessarily moving either. That means that the wall is pushing against your hand. And the strength of the push that the wall is pushing against your hand is equal to the amount of push that you're pushing against the wall. So, like the sentence, for every force there's an equal and opposite force. That's Newton's third law of motion. And that is how he was able to surmise that the stuff that makes up the planets and the stars and everything else that's not on Earth is actually made up of the same terrestrial matter that we have on our Earth. The heavens are not special or like more pure or more... They don't have a special zhuzh about them that the Earth doesn't have. You know, the heavens are not heaven. They're not a spiritual thing. They're just more stuff. More space. Okay. So now I think we're ready to talk about gravity. And why Newton's equation for gravity is what it is. I realized that there was one thing... Uh-oh. Say so. Alrighty, Sam. Okay. Oh, yes, definitely. He was very religious. But I mean, for a European living 400 years ago to 300 years ago, like, religion was, like, almost unquestioning. It's like, of course there's a god. You know. So yeah. He was also an alchemist. Which was really cool. But he was like one of the first people to actually use like scientific habits in his alchemy. So he was one of the earlier true chemists. Which is cool. And also there's a possibility he was on the autism spectrum disorder. So yeah, interesting dude. Also, I think he liked cats, which makes him even better. What the heck was I talking about? Yes, springs! And also, Isam gave me a water redeem, so I need to shut up for a sec. Hold on. Yes! Like, 1,000 years ago, you know, you could be a very devout Muslim and also a leader in your science field because the Middle East, 1,000 years ago, was like the center of learning. Like, algebra is named after a Persian guy. Crap, I want to say his name was Al-Khwarizmi, but I don't remember. Yeah. I mean, life's better now. I would rather live now than 1,000 years ago, because they didn't know... Ah, Al-Khwarizmi, okay. Damn that Persian guy. Yeah, he literally wrote the book on algebra. That's like how Europe learned about it, was because one of his books got to Italy? I don't know. A lot of, like, scholarship that Europe lost came through Italy because it was a really big trading center, like Venice and all that stuff. Okay, enough history. I need to shut up. Okay. So, a quick bit of physics that I need to cover because it helps what we're talking about. Springs. An important thing about springs is that the amount of force that you use to stretch a spring from its natural resting length, so this is its rest length, and then this is how much you've stretched it, is proportional to how much of a force you've exerted on this spring. So if you pull with twice the force, then you're going to see twice the stretching of the spring. You're going to see an extra bit. Which is an incredible thing about springs, because it helps you measure relative forces. So, blah, 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 new. So let's do an experiment. Let's hang a spring from the ceiling. Put a little tray connected to that spring. And let's record the length of the spring with the tray, but then with nothing else. And we'll call that the spring's natural length. Okay, so this is its rest length, or natural length, or whatever you want to call it, doesn't matter. Now, let's take, say, a cubic centimeter of copper. Wow, I'm not drawing this very well, am I? No, whoa, I clicked the wrong place. Stop it. Okay, so... So... yeah, part of the problem is this. Okay, got it. So, let's put a cubic centimeter of copper on the tray. There. Beautiful. So, this amount of stretch is proportional to whatever force this cubic centimeter of copper is exerting on our tray, pushing it down. If we put 2 cubic centimeters of copper on our tray, so if this distance of stretch is x, then this distance of stretch would be 2x if we put 2 cubic centimeters of copper on our tray. Now, why is this cubic centimeter of copper exerting a force on our tray, pushing it down? Well, from Newton's third law of motion, if there's a force, there has to be an equal and opposite force on the thing causing your first force. Again, like if your hand is pushing against the wall, your wall is going to be pushing against your hand, and with a force of equal size, but in the opposite direction. So, the cube creating a downward force must be caused by something. It's caused by the Earth itself. That downward force is the gravitational pull from the Earth. And a really interesting thing is that we know, because of an experiment that we've done with a string stretching, depending upon the mass that we have put on a tray, shows that the gravitational force that the Earth exerts on things is proportional to the mass of the object the Earth is pulling on. If you have twice the mass, then Earth is going to exert twice the force. Now, we also said that the force of gravity was inversely proportional to the distance between an object and another massive object. Because of flux, because of number of little rays punching through surface area, and the surface area of a sphere is 4 pi r squared, yada yada yada. And I actually misspoke when I said that Newton's third law tells us that this downward force is from the Earth. No, that's just gravitation. The downward force on the tray is because the Earth is pulling on the cube. Newton's third law is saying that the force of gravity that the Earth is exerting on our cube is equal to the gravitational force that that cubic centimeter of copper is exerting on the Earth. Both of these things are pulling on each other. And they're pulling on each other with the same sized force. And you could actually experimentally verify this with a setup. Say you have a box and another box, and they have different masses. So one box has a mass m1, one box has a mass m2. You connect them to identical springs with the same rest length. And when you connect the boxes to the springs, you're holding the spring at its rest length until you've set up your experiment, and then you let go of the two boxes so that they can gravitationally attract each other and pull each other closer. If you measure the stretch of one spring, it's gonna equal the stretch of the other spring. Even though these two boxes have different masses, the force that they feel from each other is exactly the same. So that's a way to prove Newton's third law applies to gravity. Now, gravity is extremely weak. So, for masses that a human could move by themselves without, like, an exosuit, the stretching of a spring would be so bloody tiny you would need, like, an electron microscope to measure. But the principle's still there. So not only does the force of gravity depend on the mass of the object that's being pulled, it also has to depend on the mass of the object doing the pulling. Because if you increase this guy's mass, that means this guy is able to pull even harder. But since this force and this force is the same, that means increasing this mass makes this force increase. So the mass of the thing being pulled determines the force of gravity, and the mass of the thing doing the pulling determines gravity. So now we have three proportionality statements about the force of gravity. Number 1. The gravitational force is inversely proportional to the square of the distance between the massive objects that are going to be pulling each other. Number 2. The force of gravity depends on the mass of the object being pulled. And number 3, the force of gravity depends upon the mass of the object doing the pulling. This is why, at the very beginning, I talked about proportionality with functions and just basic math. So I'll just reiterate that really quick. I don't think you understand the gravity of this situation. But Oh! War Team! I don't think I've seen you before. What's up? Hi, I'm Blairk. Free math tutor. I blab about, like, random subjects when people don't have questions. And I also play games when people don't have questions. And I'm almost done blabbing. So, welcome. Okay, where the heck was I? Also, I have ADHD and it is strong. So I keep forgetting where I was. Right, so a quick refresher, and I hit my mic, sorry about that. Quick refresher on proportionality. If I say y is proportional to x, that means y equals some constant times x. Meaning a is not a function of x, but a could be a function of y. Well, no. A is not a function of y, because y is a function of x. Oopsies uppies. Yep, f of x notation, exactly. But a could be a function of other variables that y might depend upon. We just know that a is not a function of x. So d dx, if you have any experience with calculus, d dx of a would be 0 in this proportionality statement. And then you have inverse proportionality. So if I say pressure is inversely proportional to volume, that means I have an equation where pressure equals, and then some constant over volume. This constant is not a function of volume, so derivative with respect to volume of that constant would be 0. But this constant could be proportional. It could be a function of a bunch of other different things. And if you have any familiarity with chemistry, you know that for ideal gases, there's an equation called the ideal gas law. So if I solve for pressure, here is that C constant that I was talking about. N stands for the number of particles in your gas. That's a variable because you could add more particles or take away some. And T is the temperature of your gas. T is something that you could control. You can heat something up or cool it down. So this constant C is a function of other stuff. It just is not a function of volume. So that's an important thing to remember when you talk about proportionality. The proportionality constant is only constant with respect to the variable that you're talking about. It could be a function of other things. So, if I want to combine multiple proportionality statements, so like if I said I have a variable z and it's proportional to x, and I have a variable z that's proportional to y, I have two equations here, z equals ax and z equals some other constant, by. A is not a function of x, b is not a function of y, but b could be a function of x, that's a possibility. And a could be a function of y, that's a possibility. Transitive property of equality. If somebody equals something, and that something equals someone else, just set the other two equal to each other. So, a times x equals b times y. So let's divide by x on both sides. So I have a equals b times y, and the b and the y are divided by x. Remember how I said that a cannot be a function of x? Well, right here, this is saying that it is. It's saying a is proportional to the inverse of x. But... yes. But by definition, we said that a is not a function of x. So, we didn't use any false logic here. We used the transitive property of equality, and that's fine. That means that b must have some property to it that, when divided by x, gets rid of the x-ness for a, so that a is no longer a function of x. So the way that you fix it is by saying that, you know what, b is probably directly proportional to x. We said that b could be a function of x, that's a possibility. Yes, that is also true. So b is... Yep, those are equivalence classes. Okay. And if you go to, like, Zermelo-Frankel axiomatic set theory, one of the axioms for subtraction is if you have two numbers being subtracted, then it will also equal the difference of the predecessors. But that's something altogether different. I don't know. So b is probably directly proportional to x, meaning b would equal some constant times x, and this constant is not a function of x. So, taking this and putting this right there, we get a equals c times x over x times y, and now the x's divide off. So a is no longer a function of x, or at least it doesn't look like it's a function of x anymore. Which is true by definition. And we said that c was not a function of x, that's perfect, and y is not a function of x. Oh, by definition, just by the definition of proportionality. So again, if I say like y equals ax, that means that y over x is going to equal the same number all the time. So like if y equals 2x, any point where x is half of y is going to be on this line. That's the constant of proportionality, that constant isn't going to depend upon the x value. So like with a straight line, the slope doesn't depend upon what left-right position on the line you are. It's the same slope. So by definition of proportionality, your proportionality constant is not a function of that variable. It's just not. That's why. Okay. So now we have a value for a, and I already had an equation that related z with a. So right there, z equals ax. So replacing things, z equals, instead of ax, it equals cyx. And when I'm multiplying things together, it doesn't matter what order they are, so, whoops. So cxy, it just is nice to have your variables in alphabetical order sometimes. And bada bing! I had two proportionality statements, z is directly proportional to x, z is directly proportional to y, and now I have one equation that describes it. Z equals some constant that doesn't depend upon x, and also doesn't depend upon y, times x times y. So that's how you can take individual proportionality statements. It's not working from now on. That's normal. My brain doesn't work ever, so you're in good company. So we have these proportionality statements right here for gravity. So all I need to do is just take this, multiply it to this, multiply it to this, and then multiply it by some constant that doesn't depend upon the distance between the massive objects. It doesn't depend on the masses of the objects. And then set all of that equal to the force of gravity, and then I'm done. So, my force of gravity... I should have been using little g, but whatever, I don't care. Would equal the product of the masses of the objects divided by the distance between the objects squared times some proportionality constant. In the case of Newton's law of gravitation, it's big G. And big G has a value and units. I don't remember what it is, but it is a constant with respect to the masses of the objects and the distance between the objects. And that is Newton's law of gravitation. That is why Newton's law of gravitation is what it is. That's why it's GMM over R squared. So, ta-da! Thank you for coming to my TED Talk. And I think that, yeah, that's it. For at least my little mini lecture. So that's why gravity is the way it is. At least when you're dealing with objects that are not moving close to the speed of light. So, like, less than 10% the speed of light. And also when you're dealing with objects whose densities aren't beyond a certain point. Because then you have to deal with general relativity, which is what Einstein figured out when he realized how gravity actually works. Turns out, Newton just gave a rule, like a special case scenario of how gravity works. Einstein was like, oh, there's actually more to the story. He didn't say Newton was wrong, he just said that Newton didn't get the complete picture. So that's why, like, if you're an engineer and you need to, like, design a bridge... Ah, come on, they're not that bad. But, like, if you're an engineer and you're designing a bridge, you're not going to be using general relativity, you're going to be using Newton's law of gravitation. So this is an equation that is useful in a lot of different fields of, like, profession. So it helps to know why it is the way it is. And so that's why. And I'm done. I don't want to talk about it anymore. Erase the whiteboard. We're done. However, the stream is not done. Let me take a little break, and when I come back, we're going to play some more of my favorite horror game of all time. And also, I said horror, not the other word that starts with a W. Get your minds out of the gutter. Also, I was also thinking of it, so never mind. Shut up. So yeah, when I come back, we will actually play a game like traditional VTubers do. But give me, like, 2 minutes. I promise. I'll be back. I'm not going to desert you guys, ever. I'm never gonna give you up. I'm never gonna let you down, or run around, or desert you. Never gonna make you cry, never gonna say goodbye. Never gonna turn around and hurt you. That's right. That's right. You scream in terror because it's scary time. Okay, so we've already started playing this game. Oh no, people are learning. This is bad. Yes, but yeah, we're gonna start playing my favorite horror game of all time. uh, it's gonna be so good. I love it. Also, it's like 18 years old, so uh, spoilers, I guess. Yeah, PS2 era came out in 2003. Uh, and no, I didn't play it only 3 years after it came out. Shut up. Okay, so I gotta boot this sucker up. Eh. Yeah. Let me know if the audio is like really loud, because it is sometimes, and sometimes it's not. Ah. Oh. Well, what's up, EA? Um, hope you feel better. That sucks. Almost as old as me. Yeah. Um, yeah. So sit down while Grandpa teaches you a thing or two. Yeah. Like, I got stupidly lucky. My COVID shots, they just made my arm. Also, this video doesn't play. Stop. There we go. Uh, my COVID shots, they just made my arm a little sore, but that was about it. But, like, a lot of my family members, they actually felt like they got the flu for a day. And I felt bad. But it also meant that they wouldn't get the disease and then. Oh, I know! And we're not old. Not at all. Uh, uh, oh yeah, and also guys, EA ESPN, he is a streamer like me, but he's brave enough to actually show his face. That doesn't mean that wasn't like a slam at at his looks. He actually is okay looking. Stop it! Stop. Okay. Wait, no, not new game. Load. There we go. Yeah. Um, but like a channel redeem that you can do is make him dress in a Care Bear outfit. Um, so follow him and save up channel points, so you can watch a grown man dress as a Care Bear. Yeah. Okay. So Silent Hill 3, you don't really need to know much. Um, so I'm just gonna say that. It's like the joke, I'm a man of few words, and then you stop talking. Yes. Wait, load. There we go. Right now we're running around in an alternate reality version of this girl's local mall. Um, oh yeah, and balk like a chicken too. Oh jeez. Okay. Right. I'm gonna give you a quick rundown of the games. It's survival horror. Like the gameplay itself is kind of like the first couple Resident Evil games, where you're not Doom Guy. You're a person that moves kind of slow. You're not that strong. You can fight the monsters, but it's very costly to do so. So sometimes it's best just to run, and you're always on limited supplies. Uh, Silent Hill has the same kind of gameplay, but it's much, much more Japanese horror movie kind of a thing. Uh, it definitely is a supernatural kind of setting, uh, but it also makes you question whether or not the main characters are just going insane. All right, EA, take care, man. Uh, the town of Silent Hill had a cult in it that was worshiping demons, I guess. And so the town now has its own uh, malicious intelligence, in a way you could say that. But I'm also explaining it very badly. Um, so I guess the main thing to understand is that number one, Silent Hill has a cult that worships really bad things. Uh, and this character is linked to what the cult has done in some way, but she doesn't remember. If I say any more, it would kind of spoil. So I'm not going to say anything. So, like, uh, an example of how the town is a normal town, but also has a supernatural quality, you can phase between universes, I guess? So right now, we're in her local mall, but there's nothing down here. Just like you're in a pocket dimension almost kind of thing. And also, you have dead bodies everywhere. And everything looks like it's been abandoned and rusted over for like a decade. So, very urban decay, very J horror. I love it. It's so good. But to actually answer your question, no, it's not ghosts. Right. Oh! Oh, geez, what the? And see, it does really mean things to you like that, where there might not actually be a monster, but it'll, like, play sound bits that makes you think, oh, I'm in danger right now. Yeah, so the game's mean, like, extremely mean. Uh, this is an example of a monster that you face in this game. Everything is really flesh colored, slimy, and kind of sexy. But there's a reason for it, and you learn about that later on. Okay. I'm very certain, though, there isn't any living monsters here because I killed everything. See? Right here. A dog. Except that its head is cut in half. Vertically. Yet it was alive and running around trying to eat me. Okay. Now, I was doing something last night, and I don't remember. Where the... Okay, so these are our quest items. Right! Okay. So, you have, like, puzzles just like any other survival horror game. there's a function where you can combine items together. So we're actually going to do a little bit of chemistry here. So it's time to cook. But that's not this way. That's some other way. Where is that room? Oh, and another fun thing, the Resident Evil games don't do this. Silent Hill does. If you run around a lot... Oh, I guess that's not a lot. Yes! I played Resident Evil 1, like the original, and beat it a few times. I skipped 2 and 3, and then I played 4, 5, and a little bit of 6, and was very sad. I've never had a console strong enough to play 7, and so I still haven't played 8 either. But I've watched them, and they're cool. Okay, so I'm gonna stop running, and you're gonna see a mechanic that Silent Hill games are famous for. It's almost like a stamina bar, but you could still keep running. You take more damage the more out of breath you are. So you can't just run. Yep. So you have to be sure to not exhaust your character. Otherwise, their defense goes down. Crap. There's a room that I'm missing. What the? Shrek is the best anime! Yes. I agree. Welcome to the club. I'm Blair, free math tutor. I play games when people don't have questions. I'm playing through the Silent Hill games. I'm on the 3rd one. I said that once I reach 90 followers, I will play Silent Hill 4. That was a lie. I meant 50. So once that bar fills up, I will play Silent Hill 4. So if you like Silent Hill games, you come to the right place. But I also play other stuff. And I'm actually taking suggestions. So let me know. Word of warning, though, I'm poor, so I can't go out and just buy games. Yeah. Okay. Enough of me talking. I think I need to get back down to the 2nd floor. I love all your guys' names. I think that's one of my favorite parts of streaming, is just seeing all the creative ways people name themselves. It's beautiful. And then here I am, where I just was like, what's the sound of somebody clearing their throat? Blark! And, that's how my name was born. Okay, there's a hallway that I need to get to. Ah, yeah, right here. Okay, I know where I'm going now. Word of caution, my short-term memory isn't good. So I often have to look at the map because I'll forget where I am almost immediately. It's pretty bad. Which is why I like mathematics so much, because you don't have to remember exactly what you just did, because you wrote it down, so you can remind yourself. Oh, and also, I don't mind if you guys curse in my chat. I don't, mainly just to try to keep things PG-13. But as long as you guys aren't, being absolutely disgusting. So, anything that you would say around your, cousins or nieces and nephews that are still in high school, that you would feel comfortable with, that's fine. Yes, this way. Cool. Yes, that's a cabinet that I'm running into. Right. Okay, good, good, good. So there's a hallway. Okay, I'm going to turn this fan off because it's really loud. Okay, now that I can actually hear myself talk. Are those actually good? I've heard of that, and I don't know if, like, they're safe like Newgrounds games or if it's just a million malware infections waiting to happen. Okay. So we got an empty trash can here, and if we look, there is a crap ton of moths and butterflies that we gotta kill. We have not laundry detergent. We have dish soap and bleach, so maybe we can make something poisonous that they can inhale and die. Okay, but we gotta get out of here when it happens. Oh. Oh, good. Okay, good. I thought I killed myself. No, okay, we're fine. So we wait for a few seconds until all the butterflies are dead, and then we turn back the fan on. Alright, and now we are not poisoned. Good. But they are, and that's fantastic. Both. um, okay, so my life story is kind of complicated. Let's just say I almost have a bachelor's in math and physics. And because of health, I wasn't able to finish. And I realized I didn't actually understand everything that I was taught. I just kind of parroted it and was able to get A's. So this channel is me essentially sharing what I've learned, like, oh, this is why all this stuff is the way it is. Essentially. So thank you. Yeah. So I like learning for the sake of learning because it's just cool. Also, I am not trying to toot my own horn, but I want to spread the word. This channel, if I can actually make it take off, which, I mean, I don't know if it will. They're like a trillion VTubers, so who knows? Oh, hi! Oh, you punched me, you jerk. Nope. Hands off. No. Oh, okay, good. He's dead. Oh. Yeah, red is bad, so... Oh wait, no, that's not where healing items are. This is where they are. Alright, that's good. Okay, what the heck was I saying before I got attacked? Oh, if I can make this channel take off, I want to turn it into a non-profit. I'm tired of seeing people around the world not getting access to education just because they're poor, or they live in a place that's too rural, or they're in a refugee camp somewhere. It's like, No, you're a human being. You should be able to learn everything that's awesome. Yeah. So I figured, what is a cheap way of getting at least tutoring to people in communities that really, really need it? Streaming. Internet accessible devices, especially now that we're in the 2020s, aren't that hard to come by. And if you're streaming, you don't have a bunch of infrastructure or overhead that you have to pay for. The people you need to help just need to be able to get to Twitch, and then you just need to have a streaming device. And then, bada bing, you can help people. And also, being a VTuber is fun. So, so that's the plan that I have. So pretty much every one of you guys that follows and watches and all this stuff is making that idea more of a reality. So like, I am more than happy with guys just following because like I am funny and I play games. Or if you don't think I'm funny but like to watch because I'm cringe, like, well, thank you. Uh well, without going into too much history about my life, I feel like this is the first thing that I've been able to do where I feel like I can actually give back and be productive instead of being stuck in my house sad. Okay, I'm going back here. Oh boy. So, if you're familiar, like, since you're here, you probably already know what VTubers are, I'm gonna guess. If you're familiar with VShojo, like a really big collection of English VTubers, uh, I'm like Iron Mouse, but not as sick, not as pretty, and not as cool. But like, kind of a similar living situation. Kind of. Like, I can actually leave my house. It's just I don't have the energy to do so. You know what? You extra 10 points for brown nosing. That's perfectly acceptable here. I will say, this avatar that I'm using is actually, I'm surprised at how, like, okay, this is going to get loud, so I'm going to stop talking. Okay. Wait. It just walked by. Okay. Okay. So there's a door to my right. I hear another enemy in here. Oh gosh. Okay, come here, dog. I was stabbed. Hold on. There we go. Oh gosh! The dog! The dog, the dog, the dog. The dog and the stabber. Okay, die dog. And die stabber! No, the dog! Okay, oh no! Oh no, 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 no. Okay, the gun is not working. Reload. putting this back on, but we're not going to use it. We're just going to run. See ya! Oh crap, there's the door. Oh no. No, 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 go, 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 go! Ow. Oh no. Help! Stop it! Ugh. Oh, they're everywhere! Okay, is this where the door is? Is this where the door is? Oh! Okay. Holy crap. That hurt. I hate this game so much, but I love it. Help me, please. Okay. How often do I stream? Pretty much every day. So I take Fridays off, but like every day besides that, I'm usually on. Um, I have a couple panels below the screen that are like condensed versions of what you see on bigger channels. So it has like an about me section, a schedule, uh, social links. So like I have a Discord if you guys feel so inclined, Twitter, yada yada yada. Well, thank you. I would appreciate that. I need more people to harass me. So yeah, I try to be on pretty much every day. Cause like before this, oh shnikes, dang, oh, thank you. Um, is your Discord name the same as your stream name, like your Twitch name? Because I've had people join whose names were different, and I got scared because I didn't know who they were. Okay, cool. Uh, yeah. But yeah, before this, like, really, I had nothing. So that's why I stream pretty much every day, because doing this is so much better than nothing. And there's also a vice here. And guess what we have in our pockets? A walnut. Alright, what's inside the walnut? No nut in the walnut shell, just a jewel? And then a random word that I can change. Got it. Cool. Alright. As long as it's the Maddies there, then I'll most likely remember who you are. But I might also forget who you are because my memory is very, very, like, very bad. It's not because I don't like you guys, it's just, like, my health literally makes it so that I have a hard time remembering, uh, whether or not I'm wearing my glasses. Like, I will forget things like that. Uh, it's pretty fun. So that should be another inspiring message, kind of. Even someone in as much of a mess as me can do okay with math and physics. So you guys can do it too. I trust. This pattern looks like it could have been drawn in blood. I bet it's some sort of cursed symbol. Yeah, it's also the save point. No wonder my head hurts, and I feel so awful when I look at it. Oh, this symbol is also something that was really prevalent in the very first Silent Hill game. It's a symbol that the cult draws for ceremonies and stuff. And so, at the beginning of the game, this character, when you first examine a symbol, says, I actually kind of remember this, but I don't know why. Okay. And I keep hitting the inventory menu when I don't want to. Right, okay, door in front of my face. Okay, not important. What is important is that I got the moonstone, though. Oh, Right. And the door right here that's in the center of the screen has a big crescent moon on it. So I can open that door now. Okay, so here's the game plan. I'm going to open the door. I'm going to forget which direction I am. Okay, I got to turn right. Open the door, turn right. Run at the door, and pray that nothing bites me. Whoa, why is there something here now? No, 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 no. This is bad. In biology in England right now, so it's cool you're talking about them. Well, that's awesome. Also, why are you up? Why are you up so late on a Sunday? Although, if you're in college, then sleep schedules are not a thing. It's fine. Wait. I opened that door, but nothing really happened. Okay, that's not the inventory menu. Okay. How far are you in your degree program? If I may ask. Okay. Perfect. Okay. Where are we? Oh, you're doing the trifecta. I didn't fully read what you said. Also, I am so sorry about that monster. I don't have the resources to kill it, and I'm trying to figure out where the heck we are. Or what the heck we have to do. Just a typical jewel, not really from the moon. It was inside the walnut somehow. Third floor! I have to get to the third floor. Right. Okay. The third floor is where the moon door is. Okay. And I hit the wrong button because I'm stupid. Yes. So, third floor. Yeah! Right there. Okay. Okay. New plan. Get to the door. So it's a different door. Maybe this one? Yes. Nope, it's not this door. Whoopsies. I'm wrong. And I hear something walking. I don't like it. Ah! Ah! Okay. Wait. I passed it. Son of a gun. I passed it. It's right there. Oh. No! No! Oh, this was supposed to be empty. No one was supposed to be here. Whoop! 3. You suck! Don't headbutt people, it's rude. There, 2 for good measure. Oh, I thought I was hurt worse than I was. Reload. Good! Then I'm not alone! Okay, and I want to conserve resources as best as I can. It's kind of different right now. I'm studying the 3 sciences, hoping to specify to one thing. Ah, med school! Ooh. Okay, mad respect for you there. What type of medicine are you thinking of doing? And I mean, if you followed me, that means you're pretty intelligent, so I think you're going to be okay with your grades. And that was only partly a joke. Son of a... Why are you here? Don't headbutt me, please. I'm begging you. Stay dead. Okay. Someone... Ah, you're alive. Oh, wait, no! Thrust! I can thrust him. Right. There's someone else. There's someone else. Where are they? Oh! No! Don't touch me! Don't touch me! Ow! Pokey. And you son of a gun. Poke your face. Okay. Kick him. Yeah, an IQ of 200 and also a heart rate of 200. General practitioner. That's really cool. Well, here's to you becoming a general practitioner. And also here's to me hopefully being able to actually get through the first, like, 2% of the game without dying. I haven't died yet, so... Doop, doop, doop. Okay. And right here... Ah! Shut up. There's nothing here. Stupid game. Alright. Stuck the moonstone into the door with a crescent. Okay. I can open it now. I don't want to open it, but I can. Okay, so I hear things walking. Where are you? Oh, they might be below me. Okay. That's okay. If they're below me, that means that they can't hit me. Also, I don't think there are any doors up here. Nope. Nope. Okay, we have to. We can't progress unless we go on the ladder. One thing is for sure, this does not have the mechanic that you do in Dark Souls where you can just slide down the ladder, so this is going to take a while. Oh, never mind, they'll just skip. Okay, so we're not getting back up. Where is it? I don't see it. There it is. Okay. 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 We have 28 bullets. I don't want to get close enough to have to do melee. so I have to be really careful and pay attention to where it's going to come out. There you are. 2, 3, 4. Okay, I can get 4 shots, and then he moves. Where's the next one? Oh, I hear you. Oh, there you are. Oops. 1, 2, 3, 4. Ah! Ah! I thought he was gunning right for me, but he's... We're okay. Where is he? Ah, I see him. 2, 3, 4. Okay, let's actually just highlight the bullets. Good. Now where? There you are. 2. Whoa. So, how's everybody's day?
What? It's the shopping mall just like before. Am I back?
Also, yes, that monster did look like a penis. Reload. There's a reason why, and you'll learn. Oh, I feel terrible because I only have 2 healing items. And I'm almost out of bullets. Yeah! Yep, and there's a reason why the monsters look the way they do. And you'll learn soon enough. Natural shop. Naturally locked. Sunshine Princess. That's everybody in chat. You are all Sunshine Princesses. Don't let anybody tell you otherwise. Ever. And Royal Grills. Okay, I think this is the way out. Yeah. So... I'm pretty sure there aren't any collectibles anywhere. Oh my gosh, are any of you old enough to remember what these are? So, back when dinosaurs roamed the Earth, if you wanted to make a phone call, you had to walk up to this box. Yes! Oh boy. The phone doesn't work. Well, we all have our hopes. I wish I could get a hold of Dad. Yeah, so right now she's trying to get back to her dad's apartment. And this is what the mall normally looks like. I am so angry. One of my actual dogs started barking. I thought it was the game, and I was about to cry. I'm on a payphone trying to call home something something something. Ba da 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 da. That's a good Maroon 5 song. I like that a lot. Uh, don't ask me to sing it though, because the lead singer is very much a tenor, and I very much am not. Also, that wasn't the map. This is the map. So let's get the heck out of here.
Heather,
It's you.
what just happened?
You must be one of them.
What did I do? And what do you mean by one of them?
You're in on this with that Claudia, aren't you?
Claudia? What about her? She asked me to find you, that's all.
So you are one of them.
Claudia did all that? Look, I was just hired to find you. I'm not on anybody's side. I don't know anything about this. Why don't you start by telling me what happened here? And that monster. What the hell was that?
I don't know any more than you do. All I know is that things are getting really screwy around here, and I got a weird feeling it's got something to do with me. Maybe you're just an innocent bystander, but I can't feel sorry for you because you dragged me into this. You know, if you hadn't found me...
What are you talking about? What's so special about you anyway?
Zing!
If I knew that, I wouldn't be so confused, would I?
I love her.
But I know there's something. Something I've been running from and forgot for a long time. How did I remember that?
What's wrong?
Nothing.
Where are you going?
I'm taking the subway home.
Wish you didn't.
What should I do?
Hell if I know.
Okay, so since both of you weren't here yesterday, that old dude, jeez, he's probably not even old. He's probably like only 10 years older than I am. But the dude in the hat is a private detective who was hired to find the main character, but that's all we know, because that's all he said. Also, this Claudia person is a blonde woman wearing a black dress. Oh yeah, that guy's fashion sense I really like. Like, unironically, I think he looks cool. The Claudia person is a blonde lady in a black dress. She's barefoot, and she doesn't have eyebrows. So you know that there's something wrong with her. But she said some, like, weird religious stuff to the main character, and then the main character passed out. And then Claudia was gone. And we were attacked by a bunch of monsters. So... here we are! Now we're trying to get home. Also, I need to, like, actually pay attention. 'Cause... the game is usually nice and gives you a map of the area that you're in, but you have to pick it up. So, you could just run by it while it's posted on the wall, and then you're forced to try to get through Labyrinth without the map. Because you were stupid and didn't pick up the map. Stop breathing hard, you're fine. Then I find out she has asthma. Okay, so... straight up, locked door, can't use. What do these even say? Growing... oh, it's a hamster! Oh, look at that! Growing strong and healthy. Minmo. And then I can't read anything else. Wait, no, it's a cat! That's a very derpy looking cat. Yeah, Minmo cat food. What does this say? Fruity Rouge. Okay. Would that be something you would ever buy your mother for Mother's Day? And also, would you wear it or would you eat it? Okay. Right, I don't have a map of this area. Weird ad. And this is like the normal city. This isn't even the alternate reality demonic city. Is this where we came from? Maybe. Yep, because here is a door. Did I miss any doors on this hallway, though? It's usually good to explore because there are random items scattered at certain places, but then you also have to realize that you might run into more monsters if you explore, so yeah. It's the normal one, and the one we live in is... I'm not high enough for these blasts of knowledge. Oh, okay, we're on a subway platform now. Never mind, we're not. Can I open this door? Nope. Can I open this one? No. Can I buy a ticket? Nope. Can't get a ticket even when I put in money. This ticket machine is broken. They're all broken. But there is a crumpled up newspaper. Anybody remember newspapers? That used to be like a vital piece of information, and like, do they even exist? Newspaper left on the top of the ticket machine. Fatal accident at Hazel Street. At about 11 p.m. on the 4th, a man waiting on the platform at the Hazel Street station fell onto the tracks and was decapitated by the arriving St. Renata College-bound train. The victim died instantly. Newspaper? Never heard of it. While police have not yet determined whether the death was an accidental or suicide. Oh, was an accident. I was like, was an accidental. What bad translators? No, it's because I can't read. Or suicide. Witnesses report that the victim did not look inebriated and seemed to jump off the platform deliberately. The victim's identity is still unknown. He was approximately 40 years old, 5 feet 10 inches tall, and was wearing a black jacket. The newspaper is 4 months old. What they're doing here now, your guess is as good as mine. Alright, so then that lock is also broken. Information. Ah! There's a subway map here. But even without looking at this, I still know my way home. I just need to get to... I need to get on the Bergen Street train at platform 3. Okay, but could you, like, at least pick up a map? Hey, pick... No, I want a map. I don't care that you know, I don't. Okay. What about you? Nope. Alright, and this one is probably, definitely broken. Oh! And this is Hazel Street. So this is the station where the dude jumped onto the tracks and died. Okay. That phone doesn't work. What was that, dinner? I can smell it. Dinner. Okay. Yeah, it is. The bathrooms can't get into. Oh boy. As someone with short-term memory loss, running through a game without a map is hell. Has me wondering, what is my favorite food? Oh jeez. Actually, that's a really easy question. Pizza. Hands down, bar none. That is the best meal that has ever been created. Uh, and if you disagree, you're objectively wrong. Supreme. So the works. Everything on it. Except anchovies. Because that's just way too salty. You might as well be just taking a salt shaker, unscrewing the cap, and pouring it all down your throat. That's what anchovies do. But like bell peppers, sausage, pepperoni, onion. Heck, I'm even happy with broccoli on pizza too. That's not bad. Even anchovies when you said that. See, I'm also psychic. Okay, that's a lie. I don't even like joking about that. I get really angry when people actually believe in supernatural stuff like that. Because I just expect better. Also, I was just here, wasn't I? Yeah. Like, if somebody likes astrology, but they know that it isn't really real, then that's fine. Can I go through this? Nope. I'm hitting the interact button and nothing's happening. What about one of these turnstiles? It looks like I could get in from the opening on the right side. I could hop over the top too, but that wouldn't look too graceful. Yo, what's up, Silent Hill? Oh yeah, one of our community is the actual town of Silent Hill. So, Silent Hill, everybody, Silent Hill. Saw a post where a woman aborted her child because it would be a star sign she didn't. Wait a minute. Oh, there's an open. I'm an idiot. It was open right there the whole time. Like, oh man, I'm stuck. I can't get through. There's no way. Oh, and there we go. Now I'm not going to be running around like a chicken with my head cut off. No joke, the subway, especially the quote-unquote other subway, is one of my worst nightmares. I hate it. Okay. Oh my gosh, items. Yes, please. Oh, beautiful. Beautiful. The embodiment of silence. Yeah, exactly. Don't piss him off, otherwise he will send you to a hell dimension. Also, don't do anything like murder, because then he'll also send you to a hell dimension. Matter of fact, don't do anything. Okay. I don't want to go downstairs, but I'm gonna. Okay. These are you and your weekend plans gone. Oh, a save point. Yes, please. Also, the word eco-actions, is that in Comic Sans? Or Sans? Whatever you call it? Ah! That's funny. Boom! Baby. Uh-oh, I didn't think that door would work. I don't know where it is. Okay, I don't want to go here yet. I'm not done exploring this section, so okay, back we go. What? What? The Comic Sans? What's so bad about that? Get a good look. Put here, I'm gonna walk even closer so you can get even better look. Yeah. Okay, I'm done torturing. Well, why? What did Comic Sans do to you? Oh, this door worked too. Oh, that makes sense though, because they lead to the same hallway. Right. Yes. I understand geometry. Okay, those stairs just go back to where we were. But it existed, and that's crime enough. Okay, so then this takes us to Bergen, which is where we have to go. Yeah, Bergen Street. But let's actually go through the hallway doors that I found. Maybe there are more goodies. Maybe. And not just like more monsters and jump scares. Jeez Louise! A row of phone booths, but they're all broken. Right. Oh yeah, by the way, stash your trash. Let's see. North and Hazel Street. Okay. Ooh. Oh, that makes me hungry. Good quality, good taste. Cheers. Sandwich. Alright, that is busted. I am, but that's because the every day of the week is essentially the same. Ooh, okay. Here is something we need to get through. Chains holding the doors together are secured with a bolt and a nut. The nut is screwed on tight. I can't turn it with my hands. And this is probably just... Yep. Okay. Have I explored everywhere? I want to say yes. Okay. So we have a quest location right here. We have to be able to unscrew a nut. And... okay. Ah, shut up, Heather, you're fine. Okay. So, back through here. I'm gonna save again, because I'm scared. Okay. Oh, and not all the staircases lead to the same place. Hmm. Let's go to platform 4. Because she needs platform 3. And I don't want to go there. Unless the platforms are all linked. Oh. I read this a long time ago. It's Nothing Little Occult magazine. Seemed like a bunch of crap to me. It's not so bad if you just read it for fun, though. The souls of those who died suddenly by suicide or accident don't realize they're dead. Sometimes they stay put and haunt that particular place. These spirits have lost their human senses and memories, and can only keep replaying the pain and sadness of the moment they die. Oh, yeah, oh, yeah. Because he didn't come in until after that. And then Heather walks away just saying, not my problem. These spirits have lost their human memories, yada yada. The pain can get so bad that they turn to humans for salvation. Or they begrudge humans their lives. At such times, they can possess humans. Places known as famous suicide spots or high accident areas are often to blame. You should be careful when approaching such locations, especially on the day or at the time the death occurred. That is, if you don't want it to happen to you too. That Yeah, that wasn't creepy at all. Hi, I'm this weird old man who's tailing a teenage girl. I'm not creepy at all. Also, that's totally warning us about being next to subway tracks because we might accidentally jump in because we get possessed. Cool. Which is probably about your. Uh huh. Oh no. Oh, I know what happens. Nope. There's a way to get back up. I know there is. I know there's a way to get back up. I don't. Did I do it? This is the worst part of the game. Like, the worst designed part. I hate it. This is just stupid guesswork, and I want to punch it. Ran its stupid face. Well, it's like you have to rub against that yellow section to try to jump back up. And it's just. I hate it. I wonder if it'll happen if I go the other way. Okay, I didn't read the occult book. Bergen Street. Hmm. Oh, there's nothing here. Oh, I bet you once you get pushed off, you walk back over to here, and that's how you can... Okay. Alright, so that doesn't do anything. Like, I don't mind the subway part of the game. It's just the part where you get shoved onto the tracks, and then it's like, lol, try to guess where, like, what part of the, uh, step you need to click on to get back up. Yeah, but you have to... Oh... If there's just one of you, I'm okay. Never mind, there's two. Nope. We're going back upstairs. we're climbing back all the stairs. Um... Okay, we'll do the stupid subway dodge the train puzzle. Okay, we read all that, but I'm doing it again. Doop, doop, doop. Wait a minute. I don't know. I don't think I've ever walked down here. Hmm. Are they just connected? Oh, they are. Oh. I thought there was something special about it. Apparently not. Do it. I dare you. Oof. Okay. So that's this section done. It was Douglas and not the ghost. You can still hear him creepily breathing behind your back to this day. Okay, I'm gonna save because I never want to do that ever again. Until the next playthrough. Okay. Right. Okay, now, should I fight the dogs with a gun or with a stick? Definitely the gun. Okay. Um... There should be just one long connected tunnel, so it doesn't matter which stairway I go down, right? Ooh. Thank you. Health drink. Bergen Street. Okay, that's why the staircases matter. It's because they put a little block. Now, time to play dog catcher. Come here, boy. Come here. Come here, pup, 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 pup. Which one? Fine. 2, 3, 4, 5, 6. Stated. Okay. The other dog. I don't know if the other dog is, like, stuck. He probably is, though. So... Okay. Also, that's an extreme amount of luck. Where'd he go? Okay. I don't like that I can't see you. What? Is that a technique? I can't see you. Come here. You stupid dog. Well, I'm the stupid one. Down, boy. Alright, I'm really hurt. Yeah. Okay. Now I'm only the color of slightly unhealthy urine instead of bladder infection. Cool. Bloody hell. Alright, dog, you wanna have a go? Come here. Come get me. I don't know if I can hit you from here, but I can try. Come here. Alright. Oh! That's not fair. What? I probably... Fine. Oh. Now I'm really fine. Okay. Perfect. Fantastic. Alright, I can't climb across this concrete divider. Oh, no, no, no! No, I don't want to continue. Whoopsies. Okay. Oh. Options. No. Kill me. Wonder if there is a command for just resetting. Nope. Yep. I'm pretty sure hitting continue like docks your score when you're playing the game, so I don't want to continue. And I also completely forgot. Okay, we did the ghost. We didn't do the ghost. We did the ghost part of the game. And now we play the waiting game. Doop, doop. Okay, we're good. We're good. We're good, guys. We're good. Alright, load. Oh. Maybe I can fight the dogs better this time. Look at the bright side. Okay. That's Hazel Street. St. Renata College, I bet you this is where the whole jumping off and dying bit was. Okay. If there is a little book on the floor this way, then we know we've already done it. Matter of fact, I can also look at my items. I don't remember healing. Oh well. It's not this way. Don't worry about it. Are you worrying about it? Because if you are, you shouldn't. Put worry wrinkles on your face. Only way to get rid of those is with sandpaper. And not even a fine grit, too. You gotta use the really heavy-duty stuff. Just scratch it right off. Okay, health drink. Perfect. And I think that's actually everything up here. Am I looking at something? No? Examine, examine, examine. Okay. And it is definitely blocked. Alright, everything up there. We're good. I remember healing a little bit. Alright, and here are the dogs. Unleash the hounds. Okay. We'll draw one of them to us, maybe. Ah haha, you see me, don't ya? Stay dead, okay? No! That's right. So you 7 bullets there. I'm gonna risk just use a gun here too. 4, 5, 6, 7. And kick. Alright. 14 bullets and 2 dogs. Alright, so that'll be locked. We gotta go down here. I bet you I don't even need to fight that dog. I just... What the frick?! I didn't even go the wrong way! My hands are raised up, like, in the what the heck stance. But you can't see that. So I probably should just pick my controller back up and put on my big person pants and play the game. But still, that's stupid. So you know what? I'm gonna get the health drink. I'm going to then kill the 2 dogs. And once that's done, I'm gonna go back and save. Q. Probably heal, because why not? Oh, awesome! I wanted to stab him. Life is good, life is great. 4, 5, 6, 7. 1, 2. Stay down. No. Oh, he let me reload. Screw it, I'm not saving. That was stupid. Come on, let me kill the dog. 2, 3. Alright. We're all dead. Alright. Locked. Can I bait the train? If I hop off, can I hop back on? Yes. And nothing happened. Okay. If I go here, can I interact with this concrete divider? No. So here's another experiment we're going to do. We're going to see if the dogs respawn if I go up and back down. No, they don't. So what if I go to the save point and then come back down? Hallelujah, the dogs are still dead. Okay. We're gonna save, because at least now, if I do something and die, I'm not gonna have to go through the entire fight again. Even though that fight went very terribly, and I used like 20 bullets. And my health is even lower than where I started. Yep, you know what? I'm not even gonna erase that. There we go. Okay. I never tried to go down platform 1. Instead of running all the way there, though, let's go back this way. And I think it's this way. Alright, so those dogs are all dead. I hop off. Okay. I don't want to walk too far, because otherwise I will die. Okay. So, can't interact, can't interact, can't interact. Clicking, 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 clicking. Still nothing. I really wish I could see where the door was. Ha 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 ha! Wait, is that the trick? Get on and, like, fall down and get back up? Like, as soon as you can? Nope. What the freaking stupid. I'm pretty sure if I walk any more towards the screen, I'll trigger the death and I die. This is the... Okay, yeah, no, the subway part is the worst part of this game. It's stupid. I'm not stupid, it's stupid. Alright, so we're gonna see if I can go down platform 1. So, this way. What was I looking at? The door, okay. This is the way that I did not try. I can't see. Okay. So I am meant to go this way. Oh god! Shut up. Shut up. 2, 3, 4. Ha 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 ha. Oh, and I only have 7 bullets. Perfect. That's grand. Wait a tick. Oh, there's no subway there. I can just walk right across. Okay. But that also means that the other dog could have come on over and tried to eat me immediately. Oh, ah! I hate you. I hate you. I hate you. Fight me. I was hitting the attack button! I'm gonna die. I'm gonna die. Come on, dog. I didn't know you could dodge them walking. I thought you had to be running to dodge their lunge. Okay, that's an actual game changer. Because now, if I practice, I might actually be able to fight these things. I don't want to know what that noise was. As I was saying, though, I might actually be able to fight these guys in melee, which is good because I only have 7 bullets. Also, I don't remember if there's a way to block. Oh. Path is blocked. Are there any, like, usable goodies here, though? No. Why would there be? The way is shut. It was built by those who are dead. So it's a monster there. Or here. Oh god! That was not fair. I can't see him. You son of a... Okay, I have to keep looking at them. Also, I need to swing right. Okay, I'm an idiot. I just suck at this game. Die. How dare you? Come on. I'll get him. Okay, don't worry, guys. I will get him. Come here. Get off the stairs. Fine. Is he stuck? Are you stuck? Yeah, you are. What? I hit him! Bullcrap. Just pure bullcrap. Bull honky. Bull bingus. Okay. Fine. Stairs. Here we go. Wait, why is the staircase not demented? I can open the chain with that, can't I? Información. So where on the map am I? Okay. Back up we go. Why? Why is the dog alive? That wasn't in the script. The dog is supposed to stay dead. Alright, I'm just gonna run across. See ya, sucker. Oh, I am no longer dead. Oh, whoa, there's a dead man. I'm sorry. Well, that's really nice, Heather, calling the dead man trash. Is someone sleeping here? All this red stuff around here is blood. This guy's not sleeping. Why am I not the least bit surprised? I think that nightmare's numbed my senses a little. Well, it hasn't numbed mine. I'm still terrified. Okay, what are you looking at? Is there something I missed? Yep. Okay. Oh, we got all the supplies. That's good. And we're topped off on healing. Dash up the stairs. Okay, I don't even have to really run anywhere. I just make a 180 and then go up the stairs that are right next to me. Oh gosh! Oh wow! That was a good hit. You know what? You know what? I'll give it to that dog. That was actually pretty good. Now I gotta figure out where I am. Oh. Okay, I know where we are now. And I think I can open that door now, too. So, let's open the door. I know. I'm very sorry, Heather. I am not the best. But we'll live. Okay. Now to save, because... Do I have to justify my saves? No, I don't. You either put up or you shut up. Also, I'm sorry. You don't have to shut up, you're fine. Over here? And save! Okay. Well... I'm hungry. So, I'm gonna call it here. Bada bing. It was a good day today. Met lots of new people. Thank you for the new followers. Also, old followers, thank you, because you're still cool. Just because you followed a while ago doesn't mean you're not cool anymore. And holy crap, we're only 6 away from 50. That's nuts. I've said it once and I'll say it again. Every single one of you guys that follows is making my idea of a non-profit tutoring service through streaming a reality. So, thank you. And I'll be here tomorrow. Same time, same place. Oh, also I have a Discord. If you know anybody that needs math tutoring and I'm not streaming, they can put a question in the Discord and then I'll answer it in the next stream. I have a Twitter too. But yeah. It's okay. Silent Hill, it's only a temporary parting. But before you know it, I'll be back. And you get to hear me scream and complain. Okay, I'm actually leaving now. I'll see you guys later.